Hello students! So far we have learnt about different functional groups, their names, structures and the new compounds formed by their combination with hydrocarbon chain such as the halogen group, alcohol group and the aldehyde group. Let us now move on and learn about the functional group ketone. It is similar to the aldehyde group that we studied in our previous video. But in ketone functional group, the carbon atom is bonded to the oxygen atom only. Here hydrogen is not there. That is, both the valencies of carbon are free to make bonds. Unlike aldehydes, they have only one carbon and one oxygen bonded by a double bond and are represented like this. So in contrast to aldehydes, the carbon atom can be bonded to two different alkyl groups. The ketone group is represented as -C double bond O dash. Now you think, where will hydrocarbon chain get attached to the ketone functional group? Yes, as we can see, ketones can be joined by hydrocarbon chains on both the sides of carbon. Or it could be said that an alkyl functional group can be joined by a single bond on either side of the ketone group. In general, when naming the compounds with a ketone functional group, the suffix "on" always appears after their names. Let us understand it with an example. If methyl atoms on both the sides of ketone group are joined, we get compound propanone. Yes, observe that the compound has a total of 3 carbon atoms. And can you tell me the root word for 3 carbon atom compounds? Yes, it's pro. So the original parent compound is propane, to which the functional group ketone has joined, and it becomes propanone. It has a molecular formula C3H6O, which is written as CH3COCH3. Compounds of the ketone group mainly give aroma and flavor to berries and mushrooms. In addition, they are also used in laboratories as solvents and as a stain remover. Now next is the functional group carboxylic acid. As the name itself suggests, it is an organic acidic group. The carboxylic acid functional group consists of 1 carbon atom, 1 hydrogen atom and 2 oxygen atoms. As can be seen, 3 valencies of carbon are already satisfied, 2 with oxygen and 1 with OH. And only 1 valency is now free to bond with other compounds. Just like other functional groups, this group also replaces 1 or more hydrogen atoms from the chain to form new carbon compound. To name the compounds with carboxylic acid functional group, we always add suffix oic acid behind the parent chain name. If this is the compound ethane, as you can see, it has 2 carbon and all single bonds. So the root is eth and suffix -ane. Now here, if this H is replaced by carboxylic group, here as you can see 1 carbon has increased. Thus, parent chain now has 3 carbons. So root eth becomes prop and the primary suffix is still -ane as all are single bonds. Now add oic acid as secondary suffix for the carboxylic acid functional group. So the name becomes propanoic acid, that is propanoic acid. It has the molecular formula C3H5COOH, which can also be written as CH3CH2COOH. Now what if 1 hydrogen in butene is replaced by carboxylic group? Now here, if 1 alkyl group is replaced, then we get a compound like this. Its name is butenoic acid. Students, So the root word is but for a compound having 4 carbons. Ene symbolizes presence of at least one carbon-carbon double bond. That means it is an unsaturated hydrocarbon, and oic acid is the suffix for the functional group. So remember, while formation of carboxylic acids, either one hydrogen or one methyl group can be replaced by the functional group, that is COOH. If H is replaced, then one carbon will be added to the parent chain, which is present in the functional group. But if methyl group, that is CH3, is replaced, then number of carbon atoms will remain same. As you can see, one carbon gets removed with this methyl, but one carbon gets added, which is there in the functional group. Carboxylic acids are naturally present in lemons, grapes, tamarinds, etc. And thus they are sour in the test due to the acids they contain. They are also used as souring agents in many of the food items. The next in the lists are ether and ester. We'll see them in our next video.